Hello friends, welcome to my YouTube channel Easy Aviation. Today's topic of discussion is stall strips. As you can see on the screen, there is some theory part and there are some pictures. Initially, I'll be explaining you the stall strips in a theoretical manner with the help of pictures, and later in the video, I'll be explaining you the stall strips concept with some illustration. So let's come to the theory part. So stall strips, they are the small angle that are fixed to the leading edge of the airplane wing. So they are the airplane wing as you can see on the screen, and at the leading edge, these stall strips are fitted. They are designed to manipulate the airflow over the wing so that stalls are less likely to occur. So as we are aware, the air is flowing and a part of air is flowing above the wing and another part below the wing. So these stall strips manipulate the air which is flowing above the wing, as you can see what I have written in the theory part. The word stall. So if we understand stall is a phenomena in which the airplane generates insufficient lift. As the angle of attack increases, so does the risk of stalling. So we are aware that lift is equal to half rho v square s cl. Half is the constant, rho is the density of the medium in which the aircraft is flying, v is the velocity of the aircraft, s is the surface area of the wing, and cl is the coefficient of lift, which is dependent on the angle of attack. Angle of attack is the angle, this is an aerofoil, this is the chord of the aerofoil, this is the relative airflow, and the angle between chord and the relative airflow is the angle of attack. So as the angle of attack increases, the coefficient of lift also increases. But at critical angle of attack, there is one angle of attack at which the complete aerofoil stalls. That means there is no lift generation. Why it happens? Because at particular angle of attack, the air which is flowing above the wing does not stick to the surface and it flow like this. It not happening like this. So that's why there is no lift generation. I'll be explaining that to you in the other part. So as the angle of attack increases, the risk of stalling also increases. And how the stall strips function or avoid the stalling? They creates an airflow turbulence. This is very important, and thereby adding energy to the airflow passing above the wing. So as the angle of attack increases, this stall strip, they generate turbulence in the air which is flowing above the wing, and thereby adding the energy to it to stick to the wing, the above part of the wing, so they can generate the lift. This helps the air to stick to the wing and generate lift, as I have spoken. The bottom line is that the stall strips are important safety features as they prevent stall by disrupting the airflow. Disrupting how? By creating airflow turbulence over the wing and create a boundary layer of air. I hope a little bit of stall strips is understood. So I'll be explaining using some pictures or the illustration. So as you can see the figure 1, in which the first figure, the aircraft is flying in a straight and level flight. There is no issue. This is the main wing, these are the tail wing. As the aircraft is flying, the airflow is, a part of it is flowing above the wing, a part of it is flowing below the wing, and we are aware that because of the pressure difference, where P1 is less than P2, there is a upward force, and that's how the lift is generated. But if aircraft is climbing or get into such orientation where there is no airflow above the wing, however the air is flowing like this, then in this condition the aircraft is under stall and the aircraft may fall. If we explain the same using an airfoil, this is an aerofoil, the air is flowing and air sticks at the upper edge and the lower edge, and there is a pressure difference and the lift is generated. But in such condition, the air is flowing above the wing, it does not stick, it should go like this, but it is going like this. And the below it is going in this manner, and then the lift generated is very less or there is no lift generated. And then this aerofoil is under stall. If we fit a stall strip in front of the leading edge. So what this stall strip do? The air is flowing, and because of this stall strip, the airflow which is hitting this stall strip, a turbulence is generated. Because of this turbulence, the energy is added to the airflow, which helps this airflow to stick to the upper part of the wing, and lower there is no effect. And because of this, there is some lift which is generated. How this is happening? There is an analogy. As you can see, there is a photo of a cricket ball which I have shown, and how the swinging of the cricket ball happening is in the same principle. There is a rough area, this is rough, and there is a smooth area. So because of the rough area, when this ball is thrown in a straight line, the air which is hitting the rough area, because of this minute rough area on which the airflow is hitting, there is a turbulence generated, and which helps this air to stick with the ball. However, in case of a smooth, there is no such rough or kind of a stall strip fitted. the airflow detach, and this phenomenon is known as separation, and this airflow detach, and that's how there is a resultant force in this direction, which is explained here. So that's how the ball swing. This is the same analogy which is happening in the stall strip fitted in the leading edge of the wing. So I hope you have understood. I'll just clear it, and if you have understood the concept, if you have any query about this, you can please put it in the comment section. I'm happy to resolve your queries. If you have any other topics of aviation you want me to cover, please mention it in the comment section. Please subscribe to my channel, share it to your friends. Let's make the aviation easy. Thank you.